What's up, everybody? Welcome to the 13th lecture of trig. Today we're going to be talking about double angle formulas. Before we get started with this example, I wanted to point y'all in the direction of, again, the notes. I think it's in section 2.4, and somewhere towards the middle of the notes, you'll find another table of formulas. This one will be the double angle formulas. You're going to want to have that handy just as we work through these, because we're going to use them a lot. In fact, we're going to use them for this particular problem. So to start off this problem, the first thing you're going to want to note is that the sine of 2x is equal to 2 times the sine of u, or the sine of x, times the cosine of x. So we're going to use this identity, this formula, in here. We're just going to substitute all of this in for sine of 2x. When we do that, we get 2 times cosine x plus 2 sine x times cosine x is equal to 0. Now from here, we're going to pull out the 2 cosine. We're going to 2 cosine here, 2 cosine here. So we're going to factor those out and then solve for x. Doing that, we get 2 cosine of x times 1 plus the sine of x is equal to 0. Now we know from previous examples that this must mean either 2 cosine of x is equal to 0, or 1 plus sine of x is equal to 0. We know how to solve these though. We've done these a bunch of times now, so I'll leave the rest as an exercise for y'all to complete. Having said that, let's move on to the next example. So for this next example, what we're going to use is cosine of 2x is equal to 2 cosine squared of x minus 1. Now you might already see what to do. It's pretty quick and simple from here. What we're going to do is we're going to factor out a 2 from both of those terms. When we do that, we find 4 cosine squared of x minus 2 is equal to 2 times cosine squared of x minus 1 plugging in now this formula, we get 2 times cosine of 2x. Pretty straightforward, really. Everything we're going to be doing is just going to be rewriting things based on the formulas we're given, the formulas that we have and we know. So some things worth noting then is, notice if I were to ask y'all to graph this, it would suck. Like, there's no doubt about that. That would not be a fun thing to graph. But could graph this pretty easily. That's really one of the biggest benefits of doing things like this. That and it makes other calculations a lot easier. So for example, let's say I were to give you some weird angle that you could break up into two parts. You might be able to use that then. So let's say I asked you to find the cosine of 15. Well, using this formula, you could potentially get to a place like this and just calculate the cosine of 30 instead. So this is the sort of reason we're doing this. It lets us rework the equations into smaller, more chewable, digestible problems that are just a lot better to work with. Let's look at another example. Now for this example, because there's a lot going on, I went ahead and drew some of this out. I'll explain it in just a second. But I just didn't want us to get lost in the details while we were trying to derive everything. But in this example, what we want to do is we want to find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta, provided that cosine of theta is equal to 5 over 13, and theta is somewhere between 3 pi over 2 and 2 pi. All right, so what we've got here is a situation where we know the hypotenuse is going to be 13. And we know the x value is going to be 5. We know that because of the cosine, right? We can break it up that way. So starting off, let me back up too. We also know that because our angle is between 3 pi over 2 and 2 pi, that we're going to be in this quadrant. So x is positive, y is negative, because we're in this bottom right quadrant. And because we know x is going to be 5 and the radius, the hypotenuse, is going to be 13, we're able to set up an equation using Pythagorean theorem to figure out what that y value is. Same thing we've done in the past, right? We've done this a couple of times now. Basically, we're just saying, all right, I've got this triangle. It has angle theta. I know the hypotenuse is 13, and I know the adjacent leg is 5. So this leg, this adjacent leg here, must be the square root of 13 squared minus 5 squared. Knowing that, we can go back to our circle over here and say, all right, well, I know it's in this bottom right quadrant, so it must be a negative value. So, explaining that part, we can start seeing some things here, right? Now we can see what sine and cosine and tangent are of theta. So we know that cosine of theta, that was already given. That's 5 over 13. And from this we can see that the sine of theta is going to be negative 12 over 13. Okay, now what we want to do next is apply our double angle formulas to calculate each one of these values. Well, sine of 2 theta is going to be 2 times cosine theta sine theta. Let's calculate that really quick. Sine of 2 theta is equal to 2 times 5 over 13 times negative 12 over 13. I'm just multiplying these. I'm taking these and plugging them into the formula and multiplying them. So from this, we get 2 times negative 60 over 13 squared. Which means this is going to come out to be negative 120 over 169. So we just found sine of 2 theta. It is negative 120 over 169. So to find cosine 2 theta, now we're going to take 2 times cosine squared of theta minus 1. So cosine 2 theta is equal to 2 times cosine squared, so 5 over 13, squared minus 1. From here, we're going to square everything. So we've got 2 times 5 squared is 25, 13 squared is 169, minus 1. So, multiplying everything by 2, we're going to get 50 over 169 minus 1. Well, we can rewrite this 1 as 169 over 169 . This is going to come out to be 119 over 169 negative, right? Negative 119 over 169. So now we can come up here and say, all right, well, we just solved for cosine 2 theta. That is negative 119 divide 169. Now, we just got to solve for tangent 2 theta, but that's just sine 2 theta over cosine 2 theta. So we can put the fractions over top of each other. That's going to give us tangent of 2 theta is equal to negative 120 over 169 divided by negative 119 over 169 So this is the same thing as multiplying the numerator by the reciprocal of the denominator. So we've got negative 120 over 169 times negative 169 over 119 Notice these are going to cancel out, and the negatives are going to cancel. So you're just going to be left with 120 over 119. And that's all I've got for y'all today. I'm trying to keep it light today, just so that y'all can get back to studying for today or Thursday's exam. If you have any questions, by all means, please shoot me an email. Have a good one, guys.